Welcome to Invents KE. Today, we're taking an in-depth look at the Soviet Union's ambitious Venera program and the remarkable engineering advancements that allowed the most advanced human-made machines to land on Venus and study this hostile planet in our solar system. Buckle up as we explore how the Soviet Union's Venera program evolved to conquer Venus. This is where history intersects with technology. I'm your host, Jeseremi Augustine. Don't forget to hit that subscribe button to stay updated with all our latest episodes. The Soviet Union's Venera program, initiated in the 1960s, was groundbreaking but faced severe setbacks. Venus's extreme surface temperatures and high pressures initially defeated early missions like Venera 1 and Venera 2, which lost communication before reaching their target. Yet, each failure led to essential improvements that brought new insights into Venus, marking a journey of persistence and innovation. Venus has a surface pressure nearly 92 times that of Earth's, enough to crush most standard spacecraft. To handle this, engineers thickened Venera's hull and developed high-strength alloys. Venera 4, the first probe to reach Venus in 1967, was still crushed during descent but successfully transmitted atmospheric data, showing the planet's thick layers of carbon dioxide and sulfuric acid clouds. These early data allowed Soviet engineers to adjust designs for future landers, incorporating even thicker casings and reinforcing critical components. Temperatures on Venus reach over 470 degrees Celsius, hot enough to melt steel. The Venera 7 lander, launched in 1970, was the first spacecraft to survive the descent and land. Venera 7 sent data back for 23 minutes, providing groundbreaking readings of surface temperature and proving that robust heat shielding could work. These findings set a new standard, pushing engineers to develop even more sophisticated cooling for later probes. Earlier Venera parachutes couldn't withstand the extreme conditions of Venus's atmosphere, leading to partial deployment failures. For Venera 8, launched in 1972, scientists improved the heat-resistant materials and optimized the parachute's deployment altitude, allowing it to slow descent without exposure to the harshest layers. Venera 8 not only landed but transmitted data from the surface for nearly an hour, providing information on atmospheric pressure, wind speeds, and light levels. By the time Venera 9 and Venera 10 were launched in 1975, Soviet engineers had developed durable cameras with protective casings and advanced electronics to capture images in Venus's brutal conditions. These probes sent back the first images of Venus's rocky landscape, a world of fractured slabs and angular rocks under a yellowish sky. The successes of these missions informed later improvements, such as the color imaging capabilities seen on Venera 13 and Venera 14 in 1982. These probes provided the first color images and soil analysis from Venus, transmitting detailed surface data for over an hour. The final probes, Venera 15 and 16, launched in 1983, didn't land, but instead used radar imaging from orbit to map over 40% of Venus's surface. Despite Venus's extreme environment, each mission evolved through engineering advancements, pushing the boundaries of what spacecraft could withstand. If you enjoyed exploring the evolution of the Venera program, make sure to like, subscribe, and hit that notification bell for more fascinating stories of technology linked with history. Thanks for watching, and see you next time on Invents KE.